Quickly, I'll give you my, my quick background, and we'll jump right into it. I am the startup program lead in New York for Google Cloud, which means my job is to get deeply involved in the New York City startup ecosystem, connecting with early stage startups. That is companies everywhere from formation to about $5 million raised if it's a venture-backed company, or $500,000 to $1 million a year in revenue, anything below that. So we're trying to get into the earliest stages of the startup. And the way we do that is we partner with groups like Space Apps, Silicon Harlem, universities, communities, accelerators, venture funds, and we provide access to Google, unlike it's ever really done before for early stage startups. Core to our program is a credits program, which I'll talk about in a minute. I'm going to take this down, but I'll put it back up. For everyone who is going to participate in the Space Apps Hackathon globally, everyone gets $300 in credits to tinker around with Google Cloud and a bunch of different services that come with it, which we'll talk about today. For startups, you can get $3,000 in credits. I put eligible startups there for a reason. Eligible means two things. Either you're in a startup today, or if a startup comes out of the hackathon, that counts as well. So this link will be available for 2 months after the hackathon. So if any idea comes out of the hackathon and you actually want to follow up with it, you can. So my quick story is I joined Google about 5 months ago. I've been in New York my whole life, Manhattan mostly, and I started 3 companies here in New York over 10 years, all investor-backed. Most of the investors are New York locals, and I had various levels of success and failure, probably more failure than success, but learned a lot and was really excited when Google called me to play this role because I didn't know this type of role existed. And it lets me interact with a bunch of very cool people doing neat things. So I'm going to start with the slides we had prepared for today, but I want to make this a little more interactive and tailored for the group. So the goal here is threefold. First, I'd like to give an overview of cloud computing, then machine learning and artificial intelligence. But the whole point is to give you actual practical tools that you can use at the hackathon. So with the credits you get, plus the tools we're going to go over, you should be able to quickly put out a really powerful application or system using the tools that you get with these credits. So I'm going to start first with an overview of the Google Cloud Platform, and then we'll stop for questions in between. But just so I can get an understanding from the room, how many people here think they know what cloud computing is? Okay, on a spectrum, how many people think they really know a lot about it and they should be giving the talk right now? Okay, you can't ask questions after, but no. And then on the other side, and don't be embarrassed, how many people have no idea what cloud computing is? Anybody else? Which is fine. It's actually, the point is for it to be invisible. So I will give a high-level overview. I'll give you an overview of what it means for Google. And then, like I said, we'll open it up for Q&A, and then we'll get into more practical uses towards the end. So Google 20 years ago, almost exactly 20 years ago, set out with this mission information and make it universally accessible and useful. And they've stayed true to this mission throughout. And one of the most amazing things for me is there's 7 products, all built on Google Cloud, that have over 1 billion users each. So they really build things at planet scale. And when most of us think of Google, we picture this: a simple search engine, a design that hasn't changed in 20 years, which is amazing. And that's what we all know and love about it, and it works. Most people at Google, though, when they see this, they see something more like this. This is 20 years of infrastructure and hardware and dedicated fiber under the ocean that Google has spent billions of dollars, billions of dollars every year, building and refining to make sure that when they organize the world's information, everybody in the world can actually have access to it. And what Google has done with Google Cloud now is taken all this investment and innovation and make it available for all of us so we don't have to do any of this stuff. So there's a couple of key things, and then I'll stop selling us on Google. But one is the network. So cloud computing and just the internet in general is built on this concept of servers, machines sitting in all these locations. And Google, unlike other cloud providers and internet companies, actually built its own network. So most of the rest of the internet that we use goes on the public internet. Google doesn't. It actually has its own fiber between North America, South America, Africa, and it's building more every day. Now, most startups, it might not matter. The internet's fast enough. But if you're doing things, in the milliseconds, microseconds, nanoseconds, and you're moving information from, California to Singapore, and that little delay matters, it actually makes a huge difference. Second, something paramount for Google and super important is security. And security is at every level. So from your username and password, I know someone was asking me about that, how hard it is to reset it and all the multi-factor authentication it takes, but also all the way down to the hardware. All the servers sitting at Google's facilities actually have custom-made hardware chips on them for security purposes. So again, this is all stuff that comes with, these are all things you don't have to worry about because someone else did. So cloud at Google means a lot of things. Many products you guys all use, Gmail, Chrome, Android, Drive. What we're going to focus on today is really this bottom tier. Not so much the business platforms or the productivity tools, but really the underlying mechanisms for how to build an app, how to build a backend, a database, and how to make them all connect. And again, the purpose of all this is to enable app developers and software developers to just write code, not spend time actually, getting servers in racks or running operations or doing anything that any of us had to do 20 years ago, 10 years ago, even 5 years ago. So you should be able to, let's just use this hackathon as an example, prototype something that weekend, put it out in the world right away, see if it works, people like it, and let's say it's validated, you should be able to get into production right away and at planet scale. If it goes to 1 billion users overnight, so be it, even if it's not the best written code. So at the top of this is our compute engine. This is if you are going to be actually provisioning machines, you need a server, you have a certain operating system. I suspect that most people here won't, and I kind of recommend don't doing it, but if your needs are at this level, this is something that Google definitely provides. And these are virtualized machines. So a server is a computer, and back in the day, you would actually plug the computer in or anywhere, and if it was a website, a browser would hit it, and the two computers would talk. What a virtualized machine is a representation of that. You don't actually have to have the physical machine. There's tons of them sitting at our center. You can bring it up with the exact specs, the amount of RAM, the amount of hardware, and whatever information you need. And if it were to go down, you don't have to buy another machine. Another one will virtually pop up. It makes life a lot easier. And there's a whole bunch of other things that come that's way cheaper, and we can talk about that if you have questions. The second thing I want to talk about is Kubernetes. Who here is familiar with Kubernetes? Okay, this concept of containers, again, we're talking about these virtual machines. You can actually now, literally a concept of a container, create this virtual machine with all the specs you need and run it on your local machine and have all your developers work on it and deploy it with a single click and know you're going to get that consistency across all the different tools we use. We highly recommend it. You may or may not need this for the hackathon, but we'll talk about it. But if your startups are getting to the point where you're doing modern software development, this is what we're seeing a lot of startups using. And then finally, our app engine, what we call platform as a service. Again, this allows you to focus just on code. You can write in any language that you prefer. You can build and deploy using Kubernetes and do it at a click, and again, seamlessly scale up or down. And kind of one of the most important parts for me is that you're only paying for what you use. So even in this level, and we'll talk about this, you can build apps where if nobody uses it, you don't pay anything. Or if one person uses it for one function, you only pay for that second of usage, which I think is great for the hackathon. hopefully lots of people will be using it. But and then if you have detailed data needs, we have multiple databases. Again, I don't want to go too much detail into technology, but we can definitely talk about it after. But kind of everything you might want, whether it's a specific SQL database or you want to use some of our proprietary stuff that we built at Google, it's all available for you on Google Cloud. Again, it's a little more detail about the different types of databases, whether you need instant access type of data or stuff that you need to archive, even for the long term. You have all those options as part of Google Cloud. And that's the cloud platform in a nutshell. I know we didn't go into a lot of details from a technical standpoint, but I wanted to just open it up for questions before I move into the heavier stuff.
Any questions?
Yeah.
So if you're doing some like machine learning training and stuff, and you're going to be running on like very slow to do that containers or
yeah, you can. It's about how you configure it. We're going to talk about it a little bit. You'll see. You can get as much. You can customize as much as you need. And with the credits, we call them TPUs. You actually get access to all that stuff. You may or may not need it, especially for the hackathon. But
so I really didn't have much understanding, so I just wanted to just like kind of recap, like to see if I understood. So basically, the cloud is where data is stored. So Google has its own data centers, which then stores information for like other businesses.
Sure. Yeah. So that's one way. We do call them data centers, and data storage is a part of it. So cloud computing is everything from the storage to the actual applications. So again, this concept of a virtualized computer in the data center, there is physical computers, but you as a developer don't have to worry about that. You will still develop code and deploy it like you would a server, but again, it's all virtualized. There's a whole team of people that are managing the actual devices. So when you hear people saying cloud, I mean, you can think of it as the internet or just these data centers. My understanding of where the word cloud came from is old architecture diagrams. The network or the internet was always a cloud, so that's why they call it cloud. But it's really just, again, this virtualized concept of a physical computer.
Thank you.
Which includes storage and.
How does location affect like your application? Are you just like limited to like, let's say I build an application in the US, but I do want users in Europe to make use of it. How does Google Cloud?
Yeah, so you're not limited at all.
No.
It's all replicated. And now, if this was 20 years ago and you built a data center here, you would definitely have that problem where you would need to mirror a data center,
right.
In Europe. But this all happens under the covers now.
Okay.
Yeah.
Sorry, based on, given that you've got new regulation now in Europe and called GDPR,
Yeah.
how is that handled in terms of access, etc.?
Yeah, so.
Because there's no safe harbor laws of
Yeah. So
sorry.
I can't speak to that too much from the policy standpoint just because I don't know. I can definitely speak to it though from the startup side. Companies have had to deal with it. So large companies like Google had to do quite a bit of work. But what we're talking about here in terms of the physical location, yeah. Yeah.
Hello? Yeah. I assume that when you're talking about these virtual PCs, so basically you'd have a PC and basically on Google servers, and they would just send you the images of what's happening on the machine, right? So basically all they have to do is minimize. Well, send you this. Just the view, and that's it. That's how it's so fast, right?
Yeah, so it depends on what that view means to you. Like, you could literally run a Windows machine in the cloud and view it as if you're using Windows. Mm-hmm. But you could also run all these back-end services through a command line. So there really doesn't even have to be that. Yeah.
Okay. So it's pretty fast, but I guess it's not really fast as if you have your own PC, this is all amazing stuff. But I mean, compared to having your own super fast PC.
But remember, these servers are the ones that billions of people are hitting, right? So it's not so much about like, it's not about you using it for one application. It's for billions of people using your application.
Oh, definitely incredible. Okay, well, thank you.
Great presentation, Tej. I had a question. So cloud computing is pretty much becoming more and more ubiquitous, right? Like everyone's basically going into the cloud.
Yeah.
How do you have, I mean, maybe I missed some of it, but you were explaining how the advantages of Google's cloud, whereas AWS seems to have a pretty big share of the market. How do you compare to that?
Sure. So
why would I move from AWS?
Yeah. So a couple of things. One is just kind of that shift that a lot of us.
AWS is Amazon Web Services who aren't following this stuff.
Yeah, and there's a few others. There's Microsoft, IBM, DigitalOcean, a few other players coming into the market. So one amazing thing for startups is that this exists, right? There's been a major shift that allows us to create amazing applications, which we'll talk about, which wouldn't have been possible with without the power of cloud computing. You basically have unlimited power at almost no cost. Now, so it allows startups to do amazing things. Google's cloud differentiates in a few ways. And for full disclosure, like I said, I did 10 years of startups, 3 startups, all cloud native. I used Amazon for 2 and Microsoft for the 3rd. I never used Google. And coming in for interviewing at the job, I told them that clearly that the market share is such that you have to offer value above the commoditized piece, which is, hey, we don't have to buy servers, which is great. Everyone does that now. Google's has a few advantages that I think are fundamentally different. One is this network, this private network. Like I said, for most startups, it won't matter. But when you get to a level of scale where sending that data from here to Europe matters, you'll start noticing it. And a lot of fintech companies, big data companies, blockchain companies notice this early in their life cycle. Second, artificial intelligence and machine learning, which we'll talk about in a few minutes. Google is the best at it. And we'll talk about a couple of products. Google is very open about it. They open source a lot of their tools, so we get the power of the community building on it as well. So when, and hopefully your startup gets to that point, you can leverage everything that Google uses for its own products. And then third, for me, this is not so much a technical piece of the cloud. Like if all things were equal between any of these, this is Google, right? So even if you're not using Google Cloud for cloud computing, you're more than likely using Gmail. You're using G Suite. You might need to interact with Maps. And I think you asked me this earlier, that is all Google Cloud. So these credits that you get are specifically for cloud computing, but there's several other benefits of being part of our startup program, which is G Suite accounts, credits for the Maps API, and a bunch of machine learning things that we'll talk about in the next module that are just kind of out of the box.
Another question over here?
I know you're talking about G Suite in terms of companies that have G Suites, but for some of us who are consumers, and since Google Drive has now been separated out into different apps, can one kind of consumer go in and just play around and download some major data, bring it down in and do kind of queries in terms of Power Query?
Yeah, you can play around with Google Cloud on that. Is that what you're asking?
Yeah, exactly.
Yeah. So I'll bring this up again. There's 2 tiers of credits. There's the startup credit and the free trial.
Yeah, it kind of borderlines the AI versus.
You can play with the AI stuff.
Yeah, exactly.
Yeah, you can. And I'll show you how you can do all that.
Okay, super.
Yeah.
Thank you.
I got a question. So you talked a lot about all the really cool things about cloud computing, how you could, with a few clicks, configure an application on the cloud, deploy it real quick, scale up, have data centers everywhere, everyone can use it. I'm a software engineer. I've been developing web applications for 8 or so years. The cloud has been there for most of the time. I'm used to cloud computing. But I know a lot of people who were coding before cloud computing. Can you just highlight some of the pain points that existed before cloud computing, like the size of the DevOps teams and all the things that went into
so
that?
I can give you a couple of personal stories. I can give you a couple of analogies. So the way you're talking about cloud and pre-cloud, and you've been doing software engineering for 8 years. When I was studying it 22 years ago, people were talking about that, like similar stuff, like, but about like machine language. They would tell stories like, I used to write code in ones and zeros and have punch cards. To me, that was just like, that's not. And you know, like, and there wasn't like debugging software, and there, you know, it's like, so it's going through one of those evolutions where to the point where it won't matter if you know what cloud computing is or not. It's going to be invisible, and that's just technology evolving. But some examples. So 20 years ago, if you raised $1 million for a startup, that money was gone on leasing of hardware. Like you could not build a startup with like 20K from an accelerator. It would do nothing for you. Second, if you fast forward even 10 years, so like 10 years ago when I was doing my first startup, it was all cloud native, it was pretty raw. Like it was virtualized servers, but you were going in through a terminal, and you were back in like Linux days. You might as well have been working on your own machine, which was really cool. But the second you hit scale, that server would crash. And then you'd have to deploy others, your costs would go up, you'd have to actually architect load balancing, and you would have an entire team called a DevOps team, development operations, and they would manage how your developers deployed code, how you kept your production environment, staging environment, development environment separate, and DevOps people are amazing, and CTOs create all these processes, but you still hear nightmares of companies today where someone pushes a wrong button and production goes down for 40 minutes. That shouldn't happen. And a lot of what Google Cloud is offering, and it doesn't mean, DevOps was one of the hottest job titles before maybe data scientist. You know, like Google and the other clouds are making now this concept of no ops. Like your engineers should focus on writing code. They shouldn't worry. Like, for example, Kubernetes is this containers engine. There are DevOps teams that manage deployment of Kubernetes, like the clusters that they run on, which is kind of silly. The whole point of this is to make life easier. So a lot of stuff that we're doing on Google Cloud is so people like you can tell stories to the next generation. Like back in my day, I used to do this.
Great. Any more questions?
Just one question.
Coming up.
Could you describe a little bit more about the containers, if you could? Like,
Sure.
Or if you got, like, if you have this in front of the session, you can.
Yeah, I don't have anything in here, but we can definitely talk about it. But again, the concept being that not allowing for errors and being able to guarantee the environment that you're.
It's like the same stuff that you said about the DevOps.
Yeah.
It's more protective
and more protected, more automated, less likely to make.
don't have to depend on the team.
Yeah.
Which
And for example, your engineers working who are not necessarily ops people can actually be testing exactly in the environment that will go out to production.
Thank you.
You know? It's workflow automation, but using these buckets that are mapped to the actual environment.
You've talked a lot about the upsides, and you have not talked anything about the downside of using Google Cloud. But one question that I have is that I know for especially users that are used to using, let's say, like a pre-cloud computing, one of the concerns they have is losing control over their data. Can you talk about that?
Yeah, so we will definitely talk about that in the next next module, which is about machine learning, where it actually becomes a very interesting dilemma, right? You can do everything on your own and keep your data isolated and use all the tools, but then you're not getting the advantage of the giant data set that Google has as well. And it's a very valid trade-off. Like if you're a startup building some amazing technology, you might think, okay, I want to use your tools, but why would I make you smarter? On the flip, you can say, I hope you get a lot smarter so I don't have to work on this. And we'll talk about in the machine learning piece. Now, in terms of data and purposes, again, even though it's cloud and virtualized, there's flexibility down to almost the core levels of the computer, which obviously is not the physical hardware. You can't touch it. But you can actually build your entire system completely isolated and protected. And there's kind of levels of, it goes kind of from, from flexibility to not. The the more you want your stuff isolated, the less flexible the system is. You might need ops people, you might need to deploy your own load balancing and cross-regional stuff. And you have the access to do all that. Yeah.
Cool, so I think that wraps up this Q&A.
Yeah, I'm just gonna power through the 3 modules, but if you guys wanna take a break, we can. They all kind of build off each other, so.